In this video, I'll cover how you can use the primitives or prims workflow to create complex geometry with Substance 3D Modeler. I'll start by creating a primitive. To create a prim, I'll use the Add button in the bottom bar. In VR, I can create a primitive from the Quick Actions menu. With the primitive created, I can open the outliner to see that Modeler automatically places the primitive inside a primitive container. I'm focused on the prim inside the container, so if I create another prim, it will be placed inside the same container. Prims inside the same container can interact with each other, but I'll talk more about that shortly. Primitive containers can only hold primitives, so I can't create clay layers or other objects inside a primitive container. While I'm focused on the container, I can use the Select tool to select the prim and modify its properties. For example, when I created this primitive, I chose to make it a sphere, but I can change it to a cube and adjust the cube parameters. Each shape has different parameters that I can modify to customize the shape. Some of the parameters allow me to change how the selected primitive can be combined with other primitives in the same container. For now, I'll focus on the basic combine modes: add, carve, and intersect. I'll go over the other combine modes later in the video. To create a second primitive, I'll hold D and move the gizmo to create a duplicate. Looking at the properties in the Select tool, my new prim is set to additive mode. In additive mode, our two shapes behave like a single object, so along the border where the shapes intersect, they're joined together. If I select carve mode, the new prim subtracts from the first prim, while intersect mode only leaves the area where the two prims overlap. The color of each primitive affects carve and intersection operations. If I change the color of a carving or intersecting object, it changes the color of the clay where that primitive subtracts from or intersects with other prims. I can also change how the prims interact with each other by adjusting the blending slider. A higher blending value smooths out the connection between primitives and works whether the prims are in additive, carve, or intersect modes. The blending slider also has a settings button to change the scale of the slider. Decreasing the scale can help to create more subtle transitions. Be careful when using very high blending values, as this can impact performance and might take a while to compute. When using blending, I can change the blending type to change the look of the blended area. Right now, the sphere is carving away from the cube. But what if I want the cube to carve away from the sphere? I'll change the sphere back to additive mode, and then I'll select the cube and set it to carve mode. It seems to just disappear, leaving the sphere unaffected. This is because primitives have an order, and each primitive only impacts the objects above it in the order. You can see the order of primitives in the outliner. If I want the cube to carve away from the sphere, I need to make sure they're ordered with the sphere above the cube. I can drag and drop objects in the outliner to rearrange them, or I can use the order controls in the prim properties. Whenever I create a new primitive, it's added below other primitives, so it will affect all the other primitives in the current container if I set it to carve or intersect, or if I use the blending slider. Just like carving or intersecting objects, blending objects is also affected by order. If I select the top object and change the blending value, it has no impact. Blending an object will only affect objects above it in the order. That covers the basics of primitives, but there's a more advanced tool that we can use to take primitives to the next level: groups. I've created a small scene to show how grouping can be a powerful tool. The hexagon is at the top of this container, so all of the other primitives can affect it. I'll set the cylinder to carve mode, and since it's at the bottom of the order, it subtracts from both the cube and the hexagon above it. I'll group the cylinder and the cube by selecting them and using shortcut Ctrl-G. I can see in the outliner that the cylinder and the cube are now in a group. Creating the group hasn't changed how the cylinder and cube affect the hexagon. With the group selected, I can see that this is because the combined mode of the group is set to none. When a group's combined mode is set to none, objects inside the group behave just as they would outside a group. If I select a different combined mode for the group, like add, notice that the cylinder no longer subtracts from the hexagon, which is outside the group. Instead, the cylinder only subtracts from objects inside the group. In other words, if the combined mode of a group is set to something other than none, the group behaves like a single primitive, and the combined modes of objects inside the group will not affect objects outside the group. Primitives also support repetition. Repetition with primitives works very similarly to repetition with normal clay. There are 3 types of repetition. Mirror repetition creates a mirrored duplicate of the object across an axis. Radial repetition is next. This creates multiple duplicates of the object around an axis. The last repetition is kaleidoscope, which behaves as if mirror and radial repetition are turned on at the same time. If I create a sphere and set it to carve mode, notice that it only subtracts from the repetitions that it overlaps. If I want to repeat a cube with the sphere carved away from all the repetitions in the same way, I'll need to group both the cube and the sphere, and then apply a repetition to the group, rather than just to the cube. Before I move on to a practical primitives example, let's take a quick look at the other combined modes. These combined modes are a bit more complicated, so in all of these examples, I'll only be changing combined mode parameters for the sphere, and I won't change any settings for the cube. I'll start with inset. When I set the sphere to inset, it looks like it just disappears. This is because the depth value is set to 0. By increasing the depth, I can make the inset appear. I can adjust the inner and outer blending radius for further control over the inset's appearance. Extrude is similar to inset, but it works in the other direction, adding to the surface of other shapes instead of removing. Groove adds another slider, the width slider, that allows me to adjust the thickness of the groove that I'm creating. Tongue is like the opposite of groove, and uses the surface of the sphere to create extruded lines along the cube. Switching to repel, the sphere appears again. Repel creates a kind of force field around the sphere that pushes away at other shapes. You can control the strength of the repel effect with the blending slider. Avoid acts like the opposite of repel, where every other shape has a force field that pushes away at the sphere. You can control the strength of the effect with the blending slider. That covers the fundamentals of working with primitives, but that was a lot of information to take on at once. So as a more practical example, I'll go through the steps I followed to create this trophy using many of the techniques that we just covered. I'll start by creating the cup section of the trophy. For this, I'll use a capsule, and I'll cut off the top of the capsule by using a cube in carve mode. To hollow out the bowl, I'll duplicate the capsule, make it a little smaller, and also set it to carve mode. To add a lip to the rim of the cup, I'll create a torus and resize it to match the shape that we already have. For the stem of the cup, I'll use a cylinder. And then I'll carve away from the cylinder with a torus. I'll add a couple more cylinders for the base of the trophy. Next, I'll move on to the handles. I'll create a torus and move it into position. I can turn on mirror symmetry to create the second handle on the other side of the cup. This looks pretty good, but there's a problem. The handles are visible inside the cup. I can fix this by moving the handles up in the order, so that the capsule shape I created earlier to hollow out the cup also carves away the handles inside the trophy. Next comes the star that decorates the front of the cup. I'll use a triangle brim for this and turn on kaleidoscope symmetry. Then I'll move the triangle to create the star shape. This leaves a hole in the center that I'll fill with the cylinder. By grouping the triangles and the cylinder together, I can move the star to the front of the cup. To finish the trophy off, I'll make the plaque that sits on the base of the trophy. I'll create a cylinder and use a cube to intersect with the cylinder to create the plaque. But the intersection causes a problem. The cube intersects with all of the other primitives in the container. This is easy to fix though. I only want the cube to intersect with the cylinder, so I'll group the cube and the cylinder together. Then I'll set that group to add mode. This makes the plaque group act like its own object, so the operations inside the group don't affect the other primitives in the container. I'll change the colors, add a few more details with the groove combine mode, and the trophy is ready. I hope that this tutorial has helped you understand how to use primitives in Substance 3D Modeler. I look forward to seeing what you create. If you need more help or are interested in learning more advanced techniques, join the Substance 3D community channels with the links in the description of this video.